world history. Today we're going to be looking at the scientific revolution. It's another one of these major types of thinking changes we're going to look at here in Europe between 1400 to 1800. We've been looking at the Renaissance, the Reformation, the Enlightenment, and we're also going to be looking at the scientific revolution. And the scientific revolution is going to really kick off during the second half of this time period. Although there's going to be some little hints of it beforehand, it's going to tie together with a lot of the other movements, but we're really going to see a lot of this kick off around the 1600s. So let's first of all talk a little bit about some of the things that have come before. So in the Middle Ages, first of all, there's different dates that people give it. So if we especially talk about the early Middle Ages to Middle Ages, 1500 to about 1200, there's not a lot of education in Europe. Most science is based exclusively on Christianity and teachings of the church. So if it's in the Bible, then that's going to be what the scientific thought is of the time, because it's not really scientific. It's more superstitious than anything. Once we get to the Renaissance, 1300 to 1600, we're starting to see people investing more back into learning. They're interested in what the Greeks and what the Romans were writing about. We're interested in questioning things a little bit more. So with the Reformation coming in, people are starting to question what the church is saying. Maybe they should go back and look at what the original texts were of the Bible. So we're seeing some themes there that come up. And what we're going to see in the scientific revolution is that by the mid-1500s, there's these new groups of scientists that are beginning to question these accepted beliefs. So the beliefs of the church, the teaching of the church, they say, well, you know, it's not necessarily that they're not Christian, but they're saying, I want some validation of this. I want to experiment on this to prove that it's true. And we're going to see sometimes those things were validated, but sometimes they're going to end up with a different conclusion based on the evidence that they're coming up with. So to even add into this a little bit more, what were the specific views of science that they had in this medieval viewpoint, and then even kind of up until the scientists start testing stuff? A few major things, especially dealing with astronomy, dealt with this idea that the Earth was an immovable object at the center of the universe. Everything went around the Earth, and there's some things in the Bible that kind of validate that viewpoint, but it's not just that. So as early as Aristotle, Ptolemy, some of these early Greeks and Romans, that was kind of the accepted viewpoint, and it made common sense. So when you wake up, the sun is on one side, and then when you go to bed, it's on the other side. So it seems like it's moving around the Earth. That makes sense. It doesn't actually make sense to think that we are on a piece of rock that's hurtling through space at thousands and thousands of miles per hour. That doesn't actually work with people's lived experience. So they go with what makes common sense, and that's validated by Scripture. So that's kind of what they stick with to begin with. And there are those ideas within Christianity that, you know, kind of Earth is at the center of the universe. So that wasn't something that most people questioned during the Middle Ages. But we're going to have some people that start to question some things. So we've got some European exploration going on. So people are starting to do more research about astronomy so they can chart the stars better, so they can sail in a more accurate fashion as they start going on these long, distant voyages across the ocean. A lot of that navigation is by the stars. So it's very important to have accurate maps and to have accurate ways of being able to tell where you are. So this is instigating more research into this. And then once that research is being done, we're having the printing press spreading those ideas and encouraging learning. So we have lots of people asking questions. We have people working on better instruments, better everything. So it's kind of inevitable that some of these things are going to come up at this point. Okay, so let's talk about this changing idea of how to do science. So the old science, like we mentioned, relied on ancient teachings. It relied on church teachings. And we're going to be moving to this new type of science, which is based around the scientific method. Now, there's lots of different ways you can write out the scientific method, so I'm not as much interested for our purposes exactly the order, but the scientific method is going to have some basic steps, and science teachers sometimes teach it slightly different depending on the terminology they like. But basically, you're looking at the world around you, you're making some observations, and then you find something that you want to test. You have some sort of idea about how something works, and so you have a hypothesis. Hypothesis is something that you can actually gather evidence and prove or disprove. And From that, you create your experiment of some sorts, or you collect your data of some sorts to see if it validates your hypothesis. Does it actually match up with that idea that you had? Can you prove that that is seeming to be the case, or can you disprove it? And then you kind of analyze it, create new hypotheses, etc. And this way of actually trying to gather evidence to back up thoughts about scientific things wasn't done in an organized way in the recent history here. So this is a pretty new idea. So let's look at a couple of the most notable people of time. There's obviously a whole bunch, but a few that I want to highlight especially deal with astronomy. So Copernicus is a big name in the beginnings of all of this. So when we talked about the Earth as being the center of the universe, this is an idea called called geocentric theory. Geology, the Earth. That was kind of the thought of the time, that we had a geocentric universe, an Earth-centered universe. And he started to do some analysis. He's looking at what he is noticing from patterns of planets moving and things like that. And he starts to think that maybe that's not right. It seems that actually the sun was at the center of the universe. That would make more sense with how planets were moving. And so he proposes this heliocentric universe, this idea that the Earth and the planets revolve around the sun, not the Earth. And this was like a big deal. He actually didn't publish his works until right around the time that he died, because he was so afraid that people were going to ridicule him, but even more so, like, this is kind of heresy. This is going against the church. This is something that could get you in big, big, big trouble. Thankfully, it's something that was validated by other scientists of the time. So Kepler, for example, he was publishing right around 1600. In his work, he actually proved that the basic ideas behind Copernicus's theory was true. So now we have a couple of people writing and saying the same thing. So there starts to be more and more evidence in favor of this new theory, this heliocentric theory. Another major figure, and the last one I want to talk about for now, although there's many more you could look at. You could look at your Isaac Newtons and your Francis Bacons and all these different important figures. But as far as astronomy goes, Galileo is another example, and probably the reason, what happens to him is kind of what Copernicus was afraid of. But Galileo, living at about the same time, he does a lot of experiments with things like gravity, trying to figure out how fast items fall and things like that, dropping items off of the Leaning Tower of Pisa, doing all kinds of stuff. But one thing that he's known for is for building a better telescope. Now, it's not there wasn't anything that functioned as a telescope before this, but he creates a much better system that can see a little bit further. And he starts publishing his observations. And I kind of imagine him as being pretty obstinate. Now, the ideas that he found supported Copernicus, supported Kepler. It's all in line. They're all validating each other. But when he published, we're really seeing the backlash from the church. This was seen as a threat. And he actually goes before the Inquisition. So this was like a panel to decide whether or not your teachings were in line with the church, or were you a heretic, someone that had false teachings. And if you remember from the Reformation, this could be something that could end up with you burning at the stake. So this was a serious threat. Now, in his case, they put him under house arrest until he died, and he lived there for the rest of his life. He couldn't go out in public. He couldn't teach publicly. He couldn't do anything like that. But I mean, this is a major threat. So this new way of doing science, this way of using the scientific method, is a major change from the religious base of just accepting what was told. So now we have these individuals that are thinking more outside of the box. We have more individualism, more humanism, and much more exploration of new ideas in a very logical and methodical way. So if you have any other questions about that, please talk to your teacher. Thank you.